Yes. Okay. Hello, everyone. That's kind of weird. Hello, everyone. Welcome to the computer vision workshop. You're all in the right place, yes?
Yes.
All right. Okay,
Yes,
good.
sir.
You're supposed to respond to that fast, but okay. Okay. So for those of you who don't know, computer vision is a subset of computer science where we're going to be taking input from images, videos, and we're going to be doing a little bit with cameras. We're just going to be analyzing it, doing like altering the whatever input we have a little bit. And so, yeah, we are going to be doing a little bit with webcams. So do all of you have webcams with you?
Yes.
No. Okay, does anyone not have a webcam? You don't have a webcam? Wait, raise your hand if you don't have a webcam. So just three of you? Okay. You said you can't program, right? So you're not going to use it anyway. Okay. I have two extra. This one's not good. But so which one of you wants which?
Oh, sure. I don't mind.
Okay.
Wait a second.
You want to go over? I'll go over. It's going well.
It's going well.
It's going swell.
Okay. Wait, is anyone in the Zoom?
You need to use a volunteer to demonstrate the stuff.
No, it's good. It's good. Does anyone else not have a webcam? So everyone has one now? Okay, even if you don't, there's only one example we're going to do where you absolutely need the webcam. There'll be alternatives for the other ones. And for like maybe 2/3 of the workshop, we're just going to be working with images. So it's all good if you don't have one. Okay, so if you guys are using PyCharm, the installations for all the libraries we're going to be using a couple libraries are going to be pretty easy. So the libraries we're going to need are OpenCV, MediaPipe, NumPy, which most of you probably already have, and then OpenCV contrib Python. So if you are, or actually if you are not using PyCharm, then you, I haven't done it in a while. I think it's just pip install OpenCV-Python for OpenCV. It might be just OpenCV, it might be CV2, but just try all of them. Try OpenCV-Python first. And the second one is MediaPipe. That's spelled M-E-D-I-A-P-I-P-E. So pip install MediaPipe. And I should write, that's for OpenCV. And then, I spelled that wrong. Contrib Python. Yeah, that's right. So those are the four libraries we're going to be using. So if you are, yeah. Close the door. Oh, okay.
Do you want us to close the windows a little for the curtains?
No, you can see it fine, right? Is it all good with the curtains? I actually don't know how to zoom in.
Press Control and scroll.
Oh, on this. Okay. Wait.
Control and scroll might work.
No.
Control plus.
Control plus isn't working either. Control Shift plus.
File preferences, font size. Wait, Upkar. So how do we download these? Like how you open the CMD thing to do the pip?
Yeah, give me 1 second. How do you increase the font size?
It might have been there, like in appearance. Might be like it's not
In appearance and behavior, maybe? It could, or search font. There you go. And then make that like 25 or something. 20.
Is that
might
good?
be a little big, but you can change that.
Is that good? Or
Yeah.
that's good? Okay. Okay. So you can all see it fine then, right?
Yes.
Okay. So if you're not on, I'm not using PyCharm, you're just gonna go command prompt and you do pip install OpenCV dash Python. It might be just OpenCV with no dash Python. I don't remember, I haven't done it in a while, but just try all of these. And if it doesn't work, let me know. If you are using PyCharm, it's really easy to install libraries. You're just gonna go settings. Then under project, you're gonna go to Python interpreter. And you can see there's all the libraries I have installed right now. You're gonna go plus, and you'll search up whatever library you're trying to install. And for computer vision, I would recommend using PyCharm because there's one library in particular called CV Zone. It's made by a man called Murtaza Hassan. And it's a wrapper library that, you know, okay. That's what you're saying. Anyway, it's a wrapper library. It includes a bunch of libraries that are really useful when doing computer vision. I don't know if you can pip install this. Maybe you can, I haven't tried it, but it's just really easy to install it with PyCharm. But we aren't going to be using many of the CV Zone libraries today, so it's fine if you're not using PyCharm. Is everyone good with the installs?
Have a lot to follow on.
Okay, it's fine. It's being recorded if you want to look at it watch it later. Yeah. So everyone's good with the installs? Okay. So yes. Now with computer vision, the thing is we're trying to get our computer to see stuff. The thing is seeing, that's something that human beings do, or not, like living things do, not computers. The computer doesn't know how to see, so we got to teach it how to see like we do. So whenever you're doing anything with computer vision, you have some goal in mind that you're trying to accomplish. You want to think about how you accomplish that goal down to every minute operation going on in your brain. And you're trying to program your computer to do the same thing. Because again, computer doesn't know how to see. We got to teach it how to see like we do. Nobody sees better than we do. Well, I mean eagles, but you know, that's neither here nor there. You get the point. So first thing we're going to do, wait, Aston, did you share the file with them? With
Yeah, I'm
them?
not sure.
Okay.
I'll do the instruction. Can I have the Zoom link?
Yeah.
Can I have the Zoom link?
Wait, do I just wait? Can you pause the projector?
And then
How do you get the link?
more screen. Go on your other one.
I think you did.
Copy invitation. Send it this way. I want to go back. Alright.
Yeah.
Wait, that was your computer vision.
Yeah.
The invite you sent.
Yeah.
You sure?
Yeah. It's just
Yeah, you're sure it's computer vision? Like what?
it's just this one, the one that I'm in.
Okay, thank you.
Yeah. Did you share the files though?
Yeah, I'm gonna share along with this.
Okay. Oh, actually, I'm not sharing my screen in the Zoom. I just realized. Let me share screen. Okay. So I'll type the library names again because I wasn't sharing it before.
I don't know what comes off this girl.
Okay, those are the 4 libraries we're going to be using for the G at home. Aston's going to share a zip file with you in a bit, hopefully. And that file has all the examples we're going to be going over today. You can see on the left side. So you can just look ahead, see this is what we're going to be doing. There's a media folder with a couple of images and a video that we're going to be using a bit. And this folder called Cascades. I'll explain what that is when we get to it. Yes, so I'll just wait for that to be shared.
Yeah. So I'm doing Zoom link first, and I'll get it.
Okay.
I need to go on the time. You can do anything on and
No, I need to wait for the files.
yeah.
Okay. So the file was sent into the announcements chat on Discord. So just unzip that folder and
Attention, please, to the front of the class.
thank you. So just unzip that folder and all the files. So wherever you're programming, that file has to be in the same folder that you unzipped. So if you look in the media folder, inside that folder, we have a few images and a video. So we're going to start with the first image, just going to get it displayed on the screen. Everyone's going to join the Zoom. Wait, Aston, are you in the Zoom? Okay. So I got to just keep admitting people. All right, that's fine. So first thing we're going to do is just display an image. So we're going to import our package. And to import OpenCV, we're going to type import CV2. Then we're going to create our image variable. To do that, we do cv2.imRead. And for if it's an image or a video that you have a path for in your or that's in your folder, you're just going to type the path. It's in the media folder and it's called image.jpg. So that's our image variable. And so now we've imported the image. So to display it, the command is called imshow. So we're going to cv2.imshow image, not imshow. And we're going to give two parameters. The first one is just a string. I'm going to call it output. This one is, so the program is going to open up a new window where it's going to display everything that we're seeing. And so this first parameter is what the window is going to be called. And then we give the image variable that we have. And then we can do cv2.wait key. This is a delay in milliseconds. And if you put 0, it's just going to be an infinite delay. So it's going to just stay there. The Zoom thing is in my way. So there you go. We got a nice image of the Swiss Alps. You can't really see the whole thing. It's a bit big. So we'll also resize it. Okay. So actually, there are a couple basic functions in OpenCV with images that we're gonna do. There are many, but we're only gonna go through about like 4, I think, that are important that we're gonna use quite a bit today. So first one is resizing the image. So we'll call the variable resized image, and the command is cv2.resize. We're gonna give our image variable, and we're gonna give the size that we want to resize to. So it's going to be 150 by 200 pixels. And we can then just display that instead. So resized image. I can't read the error with the massive text. Oh, sorry. Wait, no, this has to be brackets. Dude, what? Where's that? Oh, participants. Actually, 150 by 200 might be small, so we'll go maybe 1000 by, I don't know, 600. That should be good. And there you go. So the image has been resized. That's good. You can see the whole thing now. Very pretty image, right? So some other commands. There are 3 others we're going to do. First is, or actually, so at this point, once we have the resized image, that's, so I'm going to be using the analogy of like how actual people see, because that's what, again, what we're trying to emulate. So now once we have resized image and we've displayed it, the computer has now opened its eyes. And that's step one to seeing, isn't it, is opening your eyes. So we got that down. Next, we want to make the image gray. The reason we do that, actually, I'll explain it after I show you. So gray image, cv2 dot cvt and we're going to give the image source again, so resized image, and we're going to write cv2 dot color underscore, the first one, bgr to gray. It says BGR because OpenCV uses blue, green, and red rather than or BGR rather than RGB. Do you guys know what RGB is? You all know what RGB is? Okay.
Red, green, blue.
Yes. But do you guys know the significance of RGB, especially in this case?
No.
Okay.
The three colors that, yeah, I don't know.
Okay. So all the pixels we have on our computer, and actually if any of you have access to a microscope, you can take your cell phone, turn it on and put it under the microscope, and you'll be able to see each of the individual pixels, and you'll see that they are all like a red, green, and blue LED arranged like that. We have red, green, and blue, and that's one pixel. And so it will just continue that pattern, red, green, blue, over and over again. And that's what pixels are made up of. And so the fact that we're able to see colors other than red, green, blue is entirely just an optical illusion. It's displaying the R, G, and B values, or LEDs. It's turning them on at different brightnesses. And maybe I can pull up a video to show you how this works. Zooming into LCD display. Okay, that's fine. No way, I spelled that right. Display. Okay. This one seems good. So you'll see what I mean here. You can see the R, G, and B on every pixel, and you see that along the edge they're starting to get a little bit dimmer, and then in the black area they're just completely off. So that's what a screen looks like up close. How long is this? He will hopefully zoom out eventually. Yeah, there he goes. Starts to zoom out. You can see that it's a little bit hard to distinguish the R, G, and B until it gets to the point where you just see white. And so this is how we're able to see colors other than red, green, and blue on our screens. It's entirely just an optical illusion. So that's the significance of RGB. And in OpenCV, we're using BGR. The reason we're converting it to gray is because with RGB, we need three values. We need a red, green, and blue value. But with a grayscale image, we just need one, which is just some shade of gray. And because it makes it a lot easier for the computer to do operations. But usually this isn't necessary, but sometimes it is. Depends on the camera, depends on the software you have. So, well, actually, we're not even using a camera this time, but depends on stuff. All right, the next command we're gonna go over is, okay, there are two more. One first is the contoured image. So I'll show you that one. Command for that is, and you'll see if you don't know what it is at the moment, you'll see in a minute. So yeah, so this is what a contoured image looks like. And these values that I gave here, these last two, they're just, both these values kind of determine how strict the program will be with what it determines to be a contour. So I believe if I make it lower, let's see what happens if I make it lower. If I make it lower, it should just detect everything as a contour if it's going to run. Yeah, there you go. So it's much messier. And I'll explain why that is in a moment, but I'm going to put it back to,
Upkar.
Yeah.
What's a contour?
Yeah, I'll explain in a minute. Yeah, so there you go, that's fine. So the way this is working is, I'm actually going to pull up the original image as well, so you can see this a little bit better. So you saw that what was happening was I was just creating lines wherever it saw fit, and the way it determines where there should be lines. I don't know, I'm not going to draw anything on the chalkboard when I pick that up. But so you see we have a bunch of colored pixels, right? And we're going to take note of the sky specifically. you'll see we have mostly blue and then a little bit of white where the clouds are, but for the most part, it looks just blue. So what's happening is the computer is looking for wherever in between 2 pixels, there is a large, or there is some difference in the color values, in the RGB values or in the grayscale values. We're using RGB, that's fine. So wherever it sees that there's some difference, it's drawing a white line of with 1 pixel at that location. But if you look, when I had it set to 0, 0, there were lines everywhere up at the top, but and that was really messy. It was really hard to tell what's going on. But when I had it at the 150 and 200, it was a little bit cleaner. So if you look here, for example, right here, there's mostly blue, just like in this area. But I can see if you look up close, you can see it's just slightly lighter here. So the computer recognizes that as a different image and a potential place for a contour. So when I had it at 0, 0, it was putting a contour there. But we're just seeing it as blue. We don't really care if there's just like a slight difference, just like a difference of 1 in the RGB values. We don't want it to draw a contour there. So that's why we had the numbers a little bit higher. We can see pretty clearly there's some differences here. So maybe we want some contours there. But the way I had it with the 150 and 200, up at the sky, it was just blue, and then it was drawing contours wherever it saw clouds. These blue and white are pretty different. So it's okay if we have contours there. Does that answer your question?
Yes.
Okay. Yeah. So we're gonna use that a little bit later on, and you'll see where. But yeah. Am I missing anything? Okay. And then the last command that we're gonna use today is blurry image. We're gonna make the image blurry. This doesn't have too much use, but we're gonna use it once today. So the command is CV2, and we can apply a Gaussian blur. That's what the command is called, Gaussian blur. Sized image, and just like with the contoured image, these values here just determine how strict, or I mean how blurry it's going to make the image, and these two here have to be an odd numbers. So no, that's resize image again. There you go, it's blurry. The reason we do that is with one of the examples we're going to do, the program doesn't work too well if you have really sharp edges. And so the blurry image just makes it so that colors cascade out a little bit. But I mean, it's not hopefully useful, but it's good. It's good enough. So those are some basic functions that we need. And now we're going to go into the first project. So, you know, when you're a kid, when you're a little infant child, what's the first thing you ever do? When you're just born, what's the first thing you do? No, you learn how to identify shapes. That's the first thing you do. And our computer is a little infant child, so we got to teach it how to identify shapes. You guys didn't do that? You guys didn't? Oh, okay. Well, I mean, that's the first thing I did. I learned how to identify shapes. I don't know. Yeah, you identify the shape of your eyelids. Exactly. So we're going to be using shapes.png in the media folder. You guys all have the media folder now, right? Or the folder, right? Yes. Okay, good. We're going to import the shapes image. We don't have much time. Is it okay if I go over because we started late? Okay, okay. So, and all the operations we're going to do onto a copy of this image, just that if we need to access the original image, we still can. So there's that. Actually, I'll open up the image so you can see it. It's just a couple of shapes. I'm sure you guys know what shapes look like, right? You guys know what shapes look like? Oh, okay, that's okay. Now you know what shapes look like. So they have colors. It's not necessary for us to turn it to gray, but like I said, it's a little bit easier for the computer to do it if it just has to look at or analyze one value than 3 for the RGB. So we're just going to turn this image grayscale. So gray image. I typed that in wrong. I did. There you go, grayscale image. We're also going to make a blurry image because, like I said, this is the example where when you have sharp edges, it becomes a little bit difficult for the program to work. And you'll see why it is in a bit. The same values as last time. And we're also going to use a contoured image. This is an example where the contoured image is helpful because we're going to be analyzing the edges of the shape. You'll see how we're going to analyze them when we get to it, but we're going to need the contoured image. I keep saying. And so what we want to do is with each of the shapes we have, we're just going to draw, like, basically just outline the shape with some lines just so you can see what it looks like. And we're going to have a function for that because this function is pretty useful in other places as well. So it's good to just make it a function. You can copy it in other programs. So there's the find contours function that we have in OpenCV that helps us find contours, as the name suggests, but of specific objects, not just the contours of the entire image, of specific large objects. So I need some method to, this is just a built-in method for it to retrieve contours. Yes, so this contours variable that we have is a list that's going to tell us, or it's a list of all the contours that the function is able to find. So we want to access them all. So we're going to go for CNT for contours in contours. So we're going to be looping through each contour we have. First thing we want to do is we want to find the area of the contour. The reason we do this, it doesn't apply so much to this image, but if you have like a really bad photocopy of an image that's got like dust particles everywhere, we don't want the program to be trying to figure out what shape the dust particles are. No point in that. So there's a built-in function again that allows us to get the area of the contours that it finds. And so we'll say if the area is greater than 500 pixels, then it's going to consider it a shape. So cv2.draw contours final image. So this is just a function to draw contours. We give it the image that we want it to draw on. We give it each contour that we want it to draw, which is what we're getting in the loop. -1 means it's going to draw everything it sees. And then we have the color and the thickness. So yes. That might just. Just run the function right now, see if something happens. Might not. Yeah, there you go. So you can see the program was able to find all the contours of all the shapes that are above 500 pixels in area. Ooh. So that's all good, fine and dandy. Yeah.
You blurred the image first, right?
Yeah.
Why do you blur it?
It just sometimes, I mean, it's not completely necessary, but sometimes it'll have trouble finding corners, especially which we're about to do. when you have like really sharp corners. If you have something that's rounded, it's a little bit easier. If the colors like cascade out, it's a little bit easier for it. Okay. So, hang on. Okay. So, oh, I just didn't do that. These next few functions are what's going to allow us to find the corners and find like where the corners are, how many corners there are on the shape, and that's how we're going to identify what shapes we have. So there's that, and this is just the contour that we're analyzing, and then true is if we're confident that we have a closed shape, closed body, which we are. So okay. Oh wait, that was specific corner, not con. So this line of code right here is going to return a list of all the points where the contours are, and it's going through each contour. So for example, if we're looking at the first shape, which is something, I don't know, it doesn't really matter if I want to show. Yeah, first shape is triangle. So it's going to go through the triangle, draw the contour. It sees that the area is above 500, or sorry, it will go through the triangle, find the area. If it sees the area is above 500 pixels, so it'll draw the contour. And then this is going to give us the number of corners on the shape, which is 3. And this here is called the resolution. The higher it is, the more strict it's going to be with what it determines to be a corner. So, and we already have the value of the corner like curve from the arc length function. So if we just give it some multiple or like some scale of that, then it should be good. And again, this is giving us a list of all the corners we have. So if we want to find how many corners we have, we can go. Have I used that variable yet? I guess not. Corners equals the length of that approx value. So that should give us the number of corners that we have. And then we're going to go. So this, no. Yeah, okay. This cv2.boundingRect function, we're going to use it a little bit. What it does is it creates, I guess, a box of best fit. I don't really know how else to describe it, around whatever it is we're trying to find. And it does this by giving us 4 variables: the X and Y position of the top left corner, and then the width and the height of the box. I should explain this as well with OpenCV, and if you have done Pygame, it's the same there. Instead of like a normal Cartesian system where we have X or positive X is going right and then positive Y is going up, the Cartesian system starts in the top left. So this is positive X, this is positive Y. It's inverted, but that's what it is. So yes. Then what we're going to do is there are also some functions to like draw stuff on the thing. They're not super, or like write and some stuff you can draw. Not all of them are super useful, so I didn't really go over them. But one that is useful is being able to draw rectangles. So we're going to give the image that we're going to draw on first positions, or the position of the top left of the rectangle, and then the width and height of it. So this is going to be x plus, or sorry, no, this is the top left and the bottom right corners that we're giving. So we're going to give x plus the width and then y plus the height. And we'll give a color, we'll make it green. And then thickness. So if we run this, yeah, there you go. It's giving a box of best fit around the shapes that we have. So that's all good. Okay, and so now, like I said, the way we're going to be identifying what the shapes are is by the number of corners we see, because you know that's how infant children do it. Probably, I don't know. I was never an infant. I mean, I would know because I was a former infant. I don't know if you guys knew that. I don't know if you guys were. But so what did I call the variable? Corners. So if corners, which is the number of corners, if it's 3, which is a triangle, you guys didn't know triangles have 3 corners. Yeah. So if we have 3 corners, we're going to identify it as a triangle. If we have 4 corners, it's either going to be a square or a rectangle. And so the way we will distinguish, I mean, of course, you guys know what squares are, right? You guys know? You know what rectangles are? No one needs me to explain what squares and rectangles are? Okay, that's good, that's good. So for those of you who don't know, the difference between squares and rectangles are that squares, all the side lengths are the same length. So what we're gonna do is we're just gonna get a ratio of the width to the height. And if they're the same length, they should be about 1. The thing is though, that these images, it might not be exactly 1, they could be just a few pixels off. So we'll give some relative error for it to just if it looks like a square, but it's just actually 1 pixel off, it doesn't matter. So say ratio equals width divided by height. The ratio is, we'll give 0.2 relative error. And if it's outside of that, if the ratio is outside of that value, those values, I'm going to say that it's a rectangle. Okay. Now, next thing we have are circles. How many corners does a circle have?
An infinite number.
That is one interpretation. Any other ideas how many corners a circle has? Is it infinite or is it finite? Especially when you're dealing with when it's appearing on a computer.
Well, based on how it identifies corners, it's probably going to say 0.
Did I not go over? Okay. Well,
Like,
no.
Okay.
Okay, because
Circumference of the circle, like that's how many corners.
no. If it was like a drawing, then yes, these would all be correct. But with like on a computer, we have pixels, so there are corners on the image. If you zoom in on a circle on your computer, really zoom in, you get a microscope, you're gonna see that it's just made up of a bunch of squares arranged like that. So it does have corners, it just has very many. So, but we've seen our image, we know that the largest number of corners we have beyond the circles is 4. So we're just gonna say if it has greater than 4 corners, we'll say it's a circle. And if you don't know how many the largest number, if you don't know that the largest number of corners you have is a 4 with a square or rectangle, you can just put some absurdly high value, because at the end of the day, if you have a 1,000 side polygon, is it really anything but a circle? So
the else statement, can you print the number of corners just so we can see what the value is?
Yeah, I can.
Just like in the else statement you were about to write.
Oh yeah,
Yeah.
for the circle.
Yeah.
It might give like something not absurdly big because we did the blur, so it's not like
Oh,
you'll see.
okay.
And then if it isn't any of that, it's not a thing. Sorry? It's not completely necessary, but it's kind of with some like edit detection models you use. Sometimes it has trouble if you have really sharp corners right at the tip of them. So it's easier for it to detect if the colors are like cascading out, if it's not going from black and instantly white, if it's going like black and then like slowly going into a different color. Yeah. But it's not completely necessary. I mean, I haven't tried it without it, but it shouldn't be necessary. If it's not any of those, then it's not a shape that we care about. Oh, and I'm gonna print. So the function to write on the function to write on the image is a cv2.putText final image. And we give a string for it to write, which is the object type. That's the string. And then I want to display somewhere like above or around the square of best fit. So we'll go like x plus 10, y plus 10. And then we give it a font. There are a bunch of built-in fonts. You can get fonts online, but it doesn't really matter. None of them look good. So, color and then thickness. And the 0.7 was font size. So that should be all. Try it. Yeah. So, did it get any wrong?
It said only 8.
Sorry?
Like the number of corners, 8. There's 8 corners on a circle. Right?
8 corner. Oh, you know what it probably is, actually, now that I'm looking at it. Let me get rid of the square of best fit. I thought it would be made way bigger, but I guess not. I think what's happening is that
Every single circle has 8 sides.
so I think it's what it's identifying as corners in the circle is this little flat bit here, here. So, I mean, I don't know for sure. That's just my hypothesis at the moment. Yeah, it does flatten out a little bit at the corners. So I guess that's what it's identifying as corners. Or
Probably at like each side where it goes like straight, right?
yeah, that's what I'm
Right.
thinking.
And then it has like a corner there.
Yeah.
Corner there. So 2 per side, 2 times 4 is 8.
That's true. 2 times 4 is 8. Although don't know for sure if that's the reason, but again, hypothesis. So yeah, now our computer has upgraded to toddler. It now knows how to identify shapes. It's now ready to be an adult and identify other things. So
More things than shapes.
there's more things than shapes. You wouldn't believe it, but there's a ton of things other than shapes. It's crazy. I know, it blew my mind. So for other detection algorithms, you guys watch YouTube, I assume. You guys watch Michael Reeves at all?
Yes.
Yes? Okay. So if you've seen his last video, the fish one, I'll pull up an image of the fish.
I'll mute the sound, by the way.
Sorry?
I'll mute the sound.
No, I'm not going to play the video. I'm just going to show you the fish. Right, if I search up Michael Reeves fish. Good image. Look at this fish. And I'll tell you right now that in his video, he actually, in a lot of his videos, he does use OpenCV. Not sure if he's using Python or C++, but it doesn't matter. So yeah, he's trying to detect this fish. And he does explain in the video how he does it. So if you know, maybe don't say anything. I don't really care. But just looking at the fish right now, anything in particular that stands out to you about the fish that we could isolate for? Yes. Nothing? Okay. Yes.
It's a different color than what's in our.
It's a very different color than the everything else. It's a very bright orange. Ironically, it's called a goldfish, not an orange fish. Makes no sense, but and in contrast to that, the tank and the wall, they're all very dull colors. So the fish stands out quite a bit, and we can pretty easily isolate for the orange pixel in the screen, and that's exactly how he's doing it in the video. Yes, nice. So I'm not gonna go too in depth how to do it because it's not a super efficient model method of efficient. It's not super. It's not a super good way to detect stuff, but I will just briefly show you kind of how it's done. And this is where you absolutely need the webcam, no alternative, but we're not going to do it too much. So in the file that you downloaded, there's this program called Color Picker. I'm not going to go over how to make it because I don't have time, but we're already running out of time. So what we need is just something with a rather distinct color. So a few stuff here I'm going to try. I have no idea how well it's going to work. In his video, he has very ideal lighting conditions and background colors. Like I said, everything was very dull. And he had constant lighting on the fish. So maybe it'll work.
Put it against the whiteboard because the whiteboard's or the green board, I guess. It's all green.
Actually, I could put it against this. That might work well.
Yeah.
No, we're not identifying fish. We're identifying colors. Okay, try that. Why did that not work? What? What? I just line 30.
Yeah.
Because
So
we still
there's a React workshop. So people want to. So yes, like
Upkar, you can go past 2:30.
yeah,
People
you
that
can
want
go
to go
back.
can go.
There's another workshop at 2:05.
So how-
preferably want to finish it before the other workshop.
okay. All right. I think I can finish it. How much time do we have? 7 minutes. So if I finish at like 2:40, we're good, right?
Yeah.
Okay. Okay, so I have my keychain. No, that's not gonna work too well. Okay, whatever. I'll just do it. I have my keychain, bright yellow color. So the screwdriver might try, it's red, and a wrench that's blue. So we'll see what works, what doesn't. So what we're doing is we're changing the HSV values of this image, which is hue, saturation, and value, which is just brightness. And you'll see, we're just gonna, no, that didn't work. We're just gonna play around with the values until on the right side, we have isolated whatever it is we're trying to, so you'll see it's like white there. Everything else is looking real weird. So we're trying to make everything but the keychain look weird or whatever it is we're trying to identify. That's good, but it's not good enough.
I'm trying to make Upkar disappear.
I'm gone. Sweet sour gone. Oh, that's pretty good, actually. That's pretty good. No, that's not working. That's crazy, right? So that's actually working pretty well. What about this stuff?
Is it only detecting yellow right now?
Might detect other colors, but so you just play around with the values until you can isolate whatever color you're trying to get for. It's picking up what? My skin. It's also picking up my skin because it's not very progressive. But anyway, it's fine. I told you this method doesn't work unless you have very ideal conditions. So that's fine. But it's isolating pretty well for what we have. So what we would do is we take this right image and we call it a mask. So we put it over the original image. Then once you have it over the, or you have the white pixels on this, on the right one, you have them disappear basically. Once you put it over the other image, the white pixels will be replaced with all the yellow pixels it's detecting. And yes, but that's all we're gonna do with that. So yes, that's fine and dandy. 15 minutes, huh? Let's see if I can do this. You sure I can?
Like, okay, preferably 2:45. If you guys love Upkar, which I love a lot, you guys can stay.
All right.
I mean, you
I'm
guys-
staying.
All right. Okay. Nice. Wait,
Well,
but doesn't someone else have to sign to the
Yeah,
Zoom? though?
Upkar, I'm sorry, I love you, but I have to go over there to set up the other workshop.
Yeah, that's fine. Right now?
I'm staying.
No.
Okay.
So,
Okay.
yeah, keep going. I'm wasting time.
Okay. Now, when you're an little infant child, after you learn how to identify shapes, what do you want to do? Identify faces. No, you're all wrong. You learn how to identify faces. It's like you guys were never children.
Why you gotta hurt us like?
Is the camera not on? Oh, the camera turned on. Oh, well, what?
No, I don't think you can do camera.
Yeah, I can't do them both, but I don't need it right now. So in the media folder, I have a wonderful image of J.K. Simmons. So we're going to try to identify his face, beautiful face. So import CV2 again. And this is where the HAR cascades are coming in. So these are all called HAR cascades. You can see we have some for like eyes, lower body, Russian plate number. Don't know what that's about. I guess you're detecting Russian license plates. I don't know. But anyway, so what these are, they were made by someone somewhere. And the way they're made is that they take hundreds of images of whatever it is they're trying to detect. So I take hundreds of images of what they're trying to find and hundreds of images of other stuff. And through machine learning, here's a buzzword, machine learning. Through machine learning algorithms, they're finding visual characteristics that are consistent between all the things they're trying to detect and then all the things they aren't trying to detect. And the more images you have, the more powerful this becomes. And these are all like pre-made ones that somebody made somewhere, but you can make these yourself as well. I'm not going to go over that. That's a whole entire workshop on its own. But I did this a while ago, for example, with tomatoes. I was trying to make like an automatic garden where a camera would be looking at a tomato and it would detect when the tomato is ripe. It would detect when it rot. And so, for example, the way it would do that is I had hundreds of images of ready tomatoes, unready tomatoes, and rotten tomatoes. And unready tomatoes are typically green. They're a bit smaller. They're maybe a little bit red, maybe a little orange, but they're not completely red yet. And then ready tomatoes, are red. They're a little bit bigger than unready tomatoes. They have a certain sheen to them. Typically, unready tomatoes are a little bit shinier, but that's not really a huge consideration. What I also could have done is, the rotten tomatoes as well. So rotten tomatoes are typically a little bit duller in color. Maybe they have some dark spots. Maybe they have some fungus growing on them, stuff like that. Maybe they're wrinkly, so they'll have like areas where it just suddenly becomes dark and then light again. Those are the wrinkles, shadows that are in the wrinkles. I also could have made it so that it would only detect tomatoes that are still on the plant. And with that, what it would do is it would look at the tomato and see around it that there are a lot of green pixels, oftentimes in the arrangement of like stems and leaves and such. And that's how it would detect if a tomato was still on the plant. But I didn't do that, didn't bother. But so yeah, you can make these yourselves. Again, not gonna go over it though. We're gonna use a pre-built one. So we're gonna call it face cascade, cv2.cascade classifier. And then we're gonna give the path for the cascade. So it's in the hard cascades. I'm gonna mistype this for sure. Hard cascades slash hard cascade frontal to called face. There you go. It's a long name. And the image we're going to be doing is of J.K. Simmons again. So cv2.imread media J.K. Simmons.png. And again, like before, we're going to make it gray again. Again, not necessary, but just so it has one value. I already explained this like 3 times now. Image gray equals cv2 dot cvt color image cv2 dot color or to gray. There you go. And so we're gonna initialize the hard cascade. So faces equals face cascade dot detect multi-scale. The gray image is what we're going to be operating on. And so these last two values, with a lot of things, you'll notice that we have two values at the end that determine how strict it is with what it's detecting. So the first number has to be greater than 1, and it can be a decimal. And the second one has to be an integer, but it can be less than 1. I don't know if it can be negative, but it can be 0. And so the higher they are, the more strict they're going to be with what they determine to be faces. So if you're using some image besides the one we're using, and you notice that, I don't know, the guy's wearing a tie and it's detecting his tie as a face. Of course, you don't want that to happen. Yeah, see, you don't want that to happen. You don't want tie face. So you're just going to increase these values until it's only detecting faces. And you can have as many faces in the image as you want. There's no like formula for what numbers you can use. You just got to kind of play with values, see what works, what doesn't. So yes. And faces, like the BoundingRect function, is going to give us an X, Y, width, and height value again for the yes. Actually, ask that question again in like 5 minutes. There's something I want to say about that. Or like after we're done this example, ask that again. So this faces variable like BoundingRect has an X, Y, and width and height integer, or not integer, value associated with it. That's the rectangle of best fit again, for the box of best fit for the face. So for X, Y, W, H faces C2 dot rectangle. No, in the bracket. And it's saying, wait a minute, what? Oh, no, it's the wrong thing. And X and Y for the top left, or yeah, top left, and then X plus width, and X plus height for the bottom, no, Y plus height, sorry, for the bottom left. And then color, we'll make it green. And then width of the rectangle is 4 pixels. And we're gonna write face. There you go. We're gonna write face. So cv2 dot put text. Brackets. Write face. I'm gonna write face. Just simply write face. So it's gonna be like above the rectangle slightly, the rectangle of best fit. I don't know if it's actually called rectangle of best fit, but I like that name. So I didn't put it wrong. Font first. And then font size, color, width. No, yeah, okay. Then show the thing. And 0 to 8, it just keep it there. So if we run this, J.K. Simmons' face, that's crazy, right? Now, did I already say the computer was an adult? Never mind. The computer was a child. Now it's an adult. There you go. That's how we're able to detect faces with just the built-in Cascade. But again, we can make them ourselves. But again, too much work for right now. Yes.
If you give it an image of multiple faces, will it be able to, like,
Yeah.
with this code, will it be able to do the thing?
Yeah, I'll find an image of multiple faces. Let me search up in Google image of multiple faces.
Yeah.
Yes, you can do this with a camera as well, but it's largely the same. So, and just for the sake of time, I'm not going to do that, but we're going to do some camera stuff and you will see, and you guys can come up here and be in the camera. Here you go. An image of multiple faces. I don't know who these three guys are, but we'll take this one. No, it's fine. So, yeah, there you go. So I can do it with multiple faces. Yeah. The for loop is why we're able to do that because we went through every face. Yeah. Otherwise, yeah, otherwise we just go through the first one that it sees. And lucky for me, I didn't have to change these values because luck. Okay, back to your question. You asked, what did you ask? I forgot what you asked.
Is this how face identification?
Okay, yeah. So like you mean on your phone or like anything in particular?
Phone.
Okay, so with phone specifically, I'm glad you said phone. When you set up facial recognition to like open your phone with the face, when you do it, you take the phone and you like pan it around your face, right? You get it from all angles. So what's happening is that while you're doing it, it's taking hundreds of images. It's like images every second, every frame. It's taking an image, right? And it has a bunch of images of your face from different angles, from the back, you know. And it's doing what I alluded to, which is when you take hundreds of images of what you're trying to detect, and it's finding consistent visual characteristics of all those images. So it's doing that. Is the door locked? Okay, no, you left. So it's doing that just very quickly while you're panning the camera around your face. Yeah, that answer your question? So not completely?
So that's how it works, right?
Yeah,
Okay.
I can tell you're not satisfied with my answer.
No, I am satisfied with it.
Okay,
Yes. I just wanted.
okay.
So kind of what it's doing, it's creating like a unique hard cascade of your specific eye.
Yeah, these hard cascades were all made in that method by someone. They're just already pre-built. And there's this website online called something. There's a website. Yeah.
Definitely a website.
So if you you can compare the visual characteristics, natural not. So if you change the code a little bit, can you make it where you look at the image and it says like this is not the face, it's not a specific person. As in like if you identify one face and then you code it in such a way that if you put different images, it can identify that it's not this person.
So identifying not just a face, but identifying a person. Yeah. So again, that's how the phones do it, because they're not looking at the way this is made. It takes hundreds of faces, just different people's faces, and it's analyzing similarities between faces in general. But when you're doing it with your phone, it's taking hundreds of images of just your face. So it's analyzing similarities between just your face. If you give it another face, it's going to see differences, and it's going to see that's not what I was programmed to identify. Does that make sense?
Then how come sometimes like even when you put like a mask on, or you have like different haircuts?
Cover your face won't recognize, but if you have like your eyes, whatever, it might recognize your eyes.
So I can't say for certain, but what I would assume is that it's not looking at. I maybe like they've been programmed to recognize features that can change, but like your eyes. I don't know if you guys knew this, but your eyes don't change at all from your birth. Your eyes, your nose shape, mouth, all that stuff. Those things are not going to change. Your haircut can change. If you're wearing a mask, I guess maybe it like resorts to just looking at your eyes. Again, I can't say for certain, but that's what I would assume is happening.
10 minutes.
10 minutes more? Okay. All right. You sure I can take that time, or should I end it?
Yeah, like you want to use the camera, right?
Yeah.
Okay. 5 to 10 minutes can get it done.
Yeah.
Okay, yeah. do
Okay.
that.
Okay. Thank you.
You
Thank you.
want to demonstrate the programs you're showing me and everything.
Yes, that's what we're doing next.
So awesome.
Okay. So Now for the last little bit, last 10 minutes, I'm gonna try to squeeze into 10 minutes. We're gonna be using the camera. You sure they're okay with it, right?
Just go, you're way too fast.
Oh, you're right. Okay, I'm sorry. Okay, so to get camera feed, what we're gonna do is cv2.video capture. And if you don't have a camera, there is a video in the media folder, and I can show you the video really quick. No, not like that. And all these examples will work if you just use the video, and I'll show you how. There's the video. That's enough of that. If you are using the video, just like with the images, you're gonna do. The screen is still sharing on the Zoom, right? So, okay. I want to make sure I got everyone with that. If you are using the video, you're just gonna do the path the same way you do with an image. If you are using your webcam, you are going to put 0 here. This is just the webcam ID. If you have only one webcam, it's going to be 0. If you have multiple, it's going to be something else. You got to find out what it is. And so we're going to create a this needs to be a variable. We're going to call it feed for camera feed or video feed. We're going to make a while loop for this to loop through all of the frames that it's in the video or in the camera feed. So this is saving the video or the camera feed in an image variable, and success is just a Boolean, whether it's able to do it successfully. Then cv2.imshow, same as before. Output, and then image. Then this little bit of code is pretty much just going to make it so that if you hit Q, it's going to exit the program. That's it. If we do that, no, wait, what? Oh, yeah, you're right. Thank you, Weston. Wait, is this an O or is it? No, I'm pretty sure it's a 0. No, that, yeah, it's a 0. Yeah. Okay, whatever. I have it open here. I'm not trying to waste time. This is the same code. No, what? Okay, it's the camera. Camera's not doing too good because I was working before. That'd be the camera. This camera's not good. There you go. Yeah, so we have a video feed now, and now we can do a lot of the same functions we're doing on images, just with video, looking at it frame by frame, and then Q to exit. Okay, I gotta go fast. Okay, so object tracking. The thing you do after you've learned how to identify faces, track objects, obviously. So we have the feed and everything already. I'm not gonna have time to do this. Okay. Yeah, okay. For the sake of time, I'm just gonna show the example and explain quickly how it's working. Okay. So here's the code to track objects. The way this is working is the same with like the machine learning way that we did with J.K. Simmons, but instead what's happening is that, or you'll see when I play this program, or on this program. So it freezes the first frame, and then I highlight whatever object I'm trying to detect, and then it's able to track it pretty well. Yeah, unfortunately, I can't go over how to do it too much, but you'll have all the code. Maybe I'll like comment it out and post it again.
So all these files are like in the thing?
Yeah, no, all the examples we're doing. So it's happening. It's pretty much doing this on a small scale, the machine learning thing. On that first frame, when we highlight the thing, it's looking inside of the box that we highlight, and it's noticing characteristics about that thing. Instead of having hundreds of images, it just has the one. So it notices that it's white. It has this LED at the top, a bunch of characteristics that other things don't have. Yes.
That is sick.
So there is,
Did it identify the object?
yeah, but instead of doing through hundreds of images, it's just the one first frame when I highlighted the thing. And then this is the coolest, this is the magnum opus of this workshop. This is, it was an adult, now it's a decrepit old man after today, after this. So this is gonna,
Blow your
you'll
mind.
see. What?
Blow my mind.
Yeah, I'm gonna blow your mind. Get ready. So this is going to take a look at my entire body. A skeleton. So what's happening here is there's some of my feet as well. So what's happening here, maybe there's 35, I think 35, I'm not for sure. But all those red dots represent one of the landmarks. And this is in the media pipe library that I talked about a bit. There's also a model to do hand specifically where it has a bunch of landmarks on your hand, and also for your face. You can do things like recognize facial expressions, stuff like that. And so each of these red dots, they have an X, Y, and Z value associated with them. The X and Y is pretty obvious. It's just where it is in the plane of what the camera sees. Anyone know what the Z is for? Yep.
The area in the circle.
No, the circle, it's just a point. The circle is just drawn there. Just it's X, Y, and Z for the each of these landmarks. Anyone know what the Z is? Oh, yep, the depth. So it's analyzing how far that landmark is from the camera. And I have a really bad camera. Even with that, it still works pretty effectively. With the way we are able to analyze depth is with two eyes. We triangulate position. And so it's able to do this pretty reliably with just the one camera. It doesn't work great with that camera, but with better cameras, it's pretty consistent. It's honestly just it's more of like an estimation based on what's around you. Like it's measuring your depth, I guess, kind of relative to what's around you. I don't know entirely how it works, but I know that bit for sure, but I don't know. But, yeah. And so this. Want to get on tangent. So this is all also happening through this was made by through machine learning, where the machine learning algorithm was able to identify where all these landmarks are. And I can show you.
I was in know where my mouth at. I have the mask on.
It's guessing.
It's guessing.
Yeah.
They're doing a back guess.
It's a pretty good. Yeah, I'll show you. Oh, you want me to keep it going? Wait, hang on.
No, it's fine. I'm not. No.
Okay.
Okay.
This is the last bit.
Last bit you're done. So that, folks, after his thing, you guys want to take walking break, whatever, 3 minutes, and then I'm gonna start the other.
Were you running it?
No, Mr. McKinsey.
Oh, okay.
No, I think React is great though. It's one of the state of the art
What
web development.
Oh, web development?
Yes.
Oh, that's.
But yeah, anyways, yeah.
You can see this image shows kind of what's happening. There are all these landmarks with a variable associated with them, and we can isolate them all individually. Again, I'm not going to show how to do it. No time, already over time. But there's one at the nose, 3 in the eyebrows, ears, mouth, and then the rest. You can also do this. MediaPipe also has a way to do this with hands, where it looks like this. You can also do it with faces. There's a lot of things you can do with MediaPipe. MediaPipe is very useful. You can do it like that as well. But yes.
Wait, actually, so the hairs and stuff, Jennifer or whoever did, so you can see that it goes around and never actually looks at the hair.
Yeah.
So yeah.
So that is it.
Quick, 3-minute like wash the legs break, and then all the workshop is gonna start.
What room is it?
The room right across. I think room 102.
Never mind. I want to